Hello, everybody. Welcome to class. Today, we're going to be diving into what some people feel is one of the most difficult aspects about research, quantitative data analysis. However, that said, it's not rocket science. And for me, it's really important to remember that because if it's not rocket science, then I can do it. I'll leave rocket science to those rocket scientists. But I have found that after 30 years of believing that I was bad at math, that I was bad at anything statistical or quantitative or anything to do with numbers, it really realized that I was simply facing an emotional hurdle, a mental hurdle, and that those mental things that I had going on in my head were not actually true. And so as a result, uh, I really kind of, said, all right, you know what? Maybe I can learn this. Let me give it a try. And I learned some approaches that worked for me to try and learn it better, notably to use statistics textbooks that were written by social workers and social work researchers. And so they used language that I was able to access. And then as a result, I fell in love with doing quantitative data analysis. Go figure. So there is hope for you too. Even if this isn't something that you're particularly interested in, or maybe you are, I just want to say don't count yourself out. And sometimes it does take a little bit of hard work, but it's interesting what you can learn when you put yourself and put your mind to it. With all of that little pep talk for getting us started today, let's dive in. So we're going to talk about this quantitative data analysis. We're going to introduce some little bits on statistics and what we do with our data and how we prepare it and then how we display it and show it to others. Um, we're not going to talk so much about research in the news. That's in your textbook. But we are going to explore, describing the relationships among variables and implications and so forth. So when we introduce statistics, I think it is worth noting here that any of the statistical methods that are being presented can have whole books or whole courses dedicated to them alone. Here we are, we're just giving one class, one broad survey of everything and everything that, or maybe just wide survey of what could be done and some of the basics of it. So that's it. We have descriptive statistics. Now, these are a little bit different. They are preliminary from maybe the deeper cause and effect type of applied statistics. Instead, these descriptive statistics are really just looking at what do we know about our sample? What are some of the ways in which we can describe them? How are they different from each other, or how are they the same with, among each other? So we look at then our population and our sample, as well as then the relationship between certain variables that are of particular interest. So I've got two images here. There's different ways in which we can show it. Basically, you can either show it graphically or with numerical data and words. And so I've got, examples of both of these, which I have. These are actually some of my work. And oftentimes, the descriptive characteristics of our variables and of our population are found first before any of the other statistics. And so because they come first, they are oftentimes in table one, as opposed to, a table coming later on. And so sometimes we'll just, shortly in short script, refer to this as table one, where all of this information can be found. and such as your age and gender and race and ethnicity and educational background, and then some of the basic descriptors of our variables of interest. And so showing how they, have some relationships. So then when we prepare our data analysis, so we've gathered it perhaps up until this point, um, and we did our figured out what our sample was going to be. Maybe we did a survey, and so now we've got all of this data that we've collected. We need to do something with it. And so there's a number of steps and things that we can do, regardless of if we ourselves were the ones who did the collecting or if somebody else did the collecting. These are all important components that we'll need to keep in mind. As a general process, I think there's two things I want you to keep in mind. One is to tidy your data, and tidying your data is a phrase, or to tidy is a phrase that's oftentimes used in statistics and among data analysts. Among, kind of rearranging and making your data all nice and neat. So that way it becomes much easier to run your analyses. The other idea here is to get to know your data. And I like getting to know my data in a way that's kind of like getting to know a person. Take your data out for coffee. That is something that I literally will do. I will grab the code book and grab my data, and I will go to a coffee shop and I will sip my coffee and I will just say, what am I looking at here? What are some of the characteristics? And so I get to know my data in a very real sense before I start doing any harder, bigger analyses. I need to know, where is it a little rough around the edges? Where does it need some additional cleaning? What are some of the patterns that initially jump out at me? So I need to get to know my data, because this then has implications for what types of analyses I can do and how I need to arrange my data in certain categories, how I need to bunch them up, things like that. So getting to know your data, it's oftentimes, good to take it out for coffee. So as part of this preparation for data analysis, we want to make sure that every case has its own unique identification number. So this sometimes could be an email address. It could be a number that a person has arbitrarily given themselves. It could be automatically generated. But we need a way of identifying that all of these responses go to this one person or to this one program. So that way we keep everything nice and neat and clean. And a lot of times this will be automatically generated from, if you run like a Qualtrics survey online, then it can give you an automatic ID number, or you can just come up with one, or you can just simply call it as person one, two, three. Start from there, and the sky's the limit. You also want to take a look and see, are there any missing data, or are there any mistakes? Are there responses? Maybe you took it down, on a sheet of paper, or the person, wrote on a sheet of paper. So you need to make sure that everything is clear, that people weren't misreading the instructions. Maybe they kind of wrote in a way that actually kind of covered two different options, these types of things. And then you need to figure out how to handle them. Um, I mean, it's simply a feature of research. It's expected that, okay, you know what? Sometimes this stuff happens. You just simply need to be forthright about what you did about it, and disclose that. It's not usually something that will make or break your research, but you need to be transparent about how you handle it. And so one of the benefits, though, of doing surveys online or by computer is that there's a lot less room for these complicating issues and errors to get put in. And so it helps to keep them streamlined much easier. Sometimes you will have open-ended questions, and so it'll be like a big text box that people can, write and fill out responses there. And so it's important then to code some of these open-end ones. Now, sometimes you'll have a list of responses, and then there'll be other, and people can write in what other is. To the extent that you can prepare for all the possible major responses, it's going to minimize the amount of others that you're going to need to then code because that does get very time consuming. But this is an opportunity to really, kind of remember your qualitative data analysis skills and to start coding and then, make sure that you have two people do the coding. So that way it's verified that yes, in fact, these codes do go with these themes. And so, especially so that'll be for like a lot of categorical data. Um, then another part of this is to create a code book. Oftentimes, well, any of the major data sets that you will have their own code book that you can download along with it. Uh, Perhaps it's administrative data and there is no code book per se, and so you might need to create that for yourself. Um, and this is basically a dictionary that identifies, which code numbers go with which categories. And so this is a really important part, and this will actually be one of the main documents that I will bring with me to when I go out for coffee with my data to see, all right, what are the different categories? Or maybe I'm trying to shop around and find a good data set to use, and I need to look at the specific questions and the specific types of responses that were indicated to know, is this actually going to help me with my research question? So one way in which this can look, it looks, like it's a very computer printed type of document. So it'll have, for instance, like the variable name as it's listed in the data set. So A6. Well, that's not very descriptive. And so then you've got the label, which you see, oh, okay. So when it refers to A6, it's saying, the question, in fact, was, what is your marital status? And the position then is kind of where did it come? Was it at the early on in the survey or did it come towards the end of the survey? So here, if it was in position 10, it came quite early in the survey. They indicate that it is a nominal, meaning that it was a name type of categorical data. And so, and then there's like a little bit of kind of computer stuff where it was aligned and how it was valued, the column width and so forth, because this was administered over, on the computer. And then we have the values and the labels. So a person could then say, all right, as I'm thinking about this, what was my marital status? And so I look and see what are the different options. Maybe I'm married, maybe I'm single, maybe I'm separated, maybe I'm divorced, maybe I'm widowed or widower. Well, there's certain, options there, and it might work for me or it might not work for me. Maybe I'm interested in people who are cohabiting. Does this actually get to that type of a person? Not necessarily. If they're cohabiting, they might not be married, but they might be committed for the long term. So is that different than being single? Is it different from, being separated or divorced? Yeah, that's a whole category that's not being included here. So that's really important for me to know, hey, this data set may not be the best one for me. Or if I'm not as, interested there, then I can, go with these categories. But as in the when I actually look at the data, it's not going to say married, single, separated, or divorced. It's actually going to have the number that corresponds with it. So if the person is married, it's going to have a one in that box. If the person is divorced, it's going to have a four. Now, sometimes folks are like, whoa, that's a little too private, and I prefer not to say. And so they are increasingly now including um, prefer not to say, and that would be, say, 99, or I don't know, and that would be, say, 98. So depending on what the question is, sometimes we'll have those prefer not to say. And sometimes, we shouldn't just immediately discount and saying like, well, the person sort of didn't answer it. That type of an answer is an answer. And so it's important for us to understand what's actually and think through what's behind that answer. Um, because, for instance, if there were some financial data and they were testing our financial knowledge, one of the things that they have seen is that women were more likely to say, I don't know, than to risk answering, a question either correctly or incorrectly. So there was something there in behind that I don't know question, response. So that's actually really, really important to think through. But this kind of gives you an example of how it would look then within a code book, and all of your variables and all of the information that's data that would be gathered is then laid out according to this. So that way you can kind of go through and see and pick out which are the variables that I want to use. Um, or it tells others then these were the options that were made available to people. So having that documentation is an important piece. Next, you want to prepare your data for analysis. We enter it all in, especially if it was just uh, you know, written down on sheets of paper, in which case you should always have at least two people go and make sure that all of the data was input correctly. Because you can make errors and it can be very tedious if you've got a large number. So you always want to make sure you've got two sets of eyes so there's no errors in the transcription. Um, if you have it done electronically, you can kind of survey it and just do a cursory spot check, make sure that everything lined up. Um, and so, that way we can ensure that, yes, this data is accurate, or these data are accurate. Excuse me, data is a plural word. And then you want to clean it. And so that again, this kind of gets to that tidying process. And so you want to check the accuracy of the information, um, and perhaps, did when somebody was doing the survey, did they answer all of the questions, or do we have gaps? How do we handle those? Does our statistical analysis require that we have a full date and complete data set, or can it handle some missing data? So we have to make some decisions about how do we handle, that partial or incomplete. We can simply delete the whole case, but then we're pulling people out who, and there may be something about certain population that didn't feel comfortable answering a question. Um, Maybe we just simply leave that part blank, but include everything else. Maybe we can do something called imputation, where we calculate and say, all right, everybody else who was of this type of a person responded with these types of answers. And so we put in kind of what those answers would be most likely to be. And so you actually build some artificial response to fill in the blanks. That's another way of handling it. So there's a lots of different ways in which you can do that. Again, you need to kind of understand what are your main goals? How big is your data set? Is it going to matter that much? How many are missing? So forth. And then once we've cleaned all our data, we now need to better understand it for ourselves, as well as figure out how to start presenting these data to our readers or to our audience. So, we take a look and see what are some of the central tendencies and what is the variability. Um, so when we talk about central tendency, we're referring to the most common value that pops up. And the variability would then be what's kind of that range, how distributed are the responses, or are they, all clustered in one area around one type of response? And one way of doing this is showing the skewness. So this is kind of the extent to which, those responses are clustered or if they're spread out. So I've got two images here. One that's kind of showing a bit more of a normal distribution. When we call a normal distribution, this normal distribution curve, we call it a little like a bell curve. So it starts out kind of low on the edges and then goes high in the middle and then low on the edge again. So the majority are towards the middle. So we call that a normal distribution. A skewed distribution would then be where we see more uh, cases that are kind of leaning towards one side. So we have very few cases in the skewed distribution side who of people who indicated 0 or 1, but a lot who indicated 3 and 4. So we see it's heavier on the high side. There's different ways in which you can display these. As I mentioned earlier, you can either use visual graphs, and they can pack a lot of information in a very easily digestible manner. So in your book, you've got exhibits 14.3, point 4, and point 5, showing a bar chart, a histogram, and a frequency polygon. These are all different tools that you can use to visually illustrate it. And then you can use frequency distributions, which was then kind of showing the just simply the numbers and showing, is what's the mean, what's the standard deviation. Maybe you've got some graphs there to show it as well. So this frequency distribution shows the numerical display of the number of cases. So for instance, number of males in my study, uh, there were 17,886 people who identified as male, and there were 17,790 people, respondents, who identified as female. So there's different ways in which you would report them. It can be in ungrouped data. It can be in grouped data, or you can have some combined data, depending on how many responses that you have. And so uh, I've got different examples here. Grouped data would, everybody maybe indicated what their actual age was, but then I group them into buckets and into categories. So I've got my younger adults who are 18 to 24, and then those who are 25 to 34. And so I've got, these 10 years of age ranges, and then 75 and above. And so this become, rather than showing every single age, grouping them helps us to manage it a bit easier, both statistically as well as visually. But then you note that I have the exact number of how many people responded within each category, as well as then a percentage of the whole, if of those ages. Then you'll also have, say, combined groups where people may have indicated that they were white or black and Hispanic. And so, because being Hispanic is an ethnicity. And so, we've got, those folks were all combined, or maybe they identified as being biracial or multiracial. And so, they identify as being both white and black, non-Hispanic, and as a result, then they would be kind of indicated under the 2+ groups. So how many people fit in there? So this has, implications then for how are we indicating people who are white, or how many people identify as black, and so forth. And so we need to kind of figure out how much do we have in each of these groups, um, and where are we, really intending to direct our research. So when we engage in, summarizing some of these univariate distributions, univariate would be one variable. And so showing that, you've got this one variable, and then you can kind of facilitate some other aspect around how it looks, and to understand it in different ways. So, that's kind of what some of those prior ones were. Uh, and so there's different ways then of understanding some of these variables than in relation to some of the others. And so there's a way in which you can do it called a crosstab. Um, and so this here is an example of a crosstab that I did, which is a bit of a fancier one where we actually have three variables. And so my question for this research was looking at social work education and do people who teach social work education consider economic justice content? Do they perceive it as being important and relevant to their work and to their teaching? And do they actually teach it? So not just believing that it's important, but that they put their actions where their mouth is. And then breaking that down by do they have master's degrees or doctorate degrees? So I kind of break them down. And so you can see then different visually different ratios that people who perceived um, to the teaching of this content as being relevant. They do teach it, and they've got doctorates. That was actually the largest group. And then you've got smaller groups of people. And what was interesting is that um, among those who did not believe that it was relevant, the majority of them had master's degrees. So does maybe having higher level of education impact one's willingness and belief that it's important to teach it? That's one of the big findings here. Then we have measures of central tendency. Hopefully, at some point, you have explored this in a statistics class or even just a regular old math class. And so you've got your mean, your median, and your mode as these measures of central tendency, and central being kind of what's in the middle. That's, what would be then the average way of thinking about this. So there's different ways of measuring it depending on what is the data, what are the data, and how is it all laid out. And so different ways of little ways of thinking about it. For me to remember, what is the mode? This is the most frequent value in a distribution. So maybe you've got, on a scale of 1 to 10, and out of 15 people who, are responding, 10 of them respond with a 9. Okay, so the mode would be then the most popular. And so this mode, I'd like to think of like a fashion magazine. It's so popular and people want to be in the mode or have the popular fashion of dress. So that's the most frequent one you see. It's the most popular in a distribution. Then you've got the median. Now, the median would be the one that's technically in the middle. As if you were to line up all of the responses, then um, what's the number that falls right in the middle, physically, if you line them all up? And the median is kind of like the median in a highway, where you've got one direction of traffic going one way, the other direction of traffic going the other way, and then the little bit of grass right between each of those is the median. So this is the average. Okay, and then you've got um, the mean is, wait a minute here. This is an error. They have it backwards. Hold up. All righty. Thank you. I found that error. Holy cow. Okay. So, all righty. Now we've got it right. So the mean is the average that you add up all of the values and then you divide by the number of cases. That is the mean. So the mean average. Whereas then the median is the one that falls right in the middle. So yeah, now that is correct. I apologize for that. See, sometimes the authors get it wrong. And then you need to have somebody else look over your work. Alrighty here. So sometimes, it's not quite clear should you pick the median or the mean. Now, the mode, that's usually only good for categorical variables. But sometimes, you've got the mean or the average would actually be really good, except you've got one really huge outlier. So maybe you're measuring, middle class Americans, and then you've got Bill Gates. And so, a billionaire. And so you're trying to average the total, average income of people. And having Bill Gates in the equation really skews the whole thing, and all of the data. So in that case, you would want to use the median, because it's less sensitive uh, to the outliers or at the ends of the distribution scale, the tails over of our scale. Whereas the mean, is good for the density, and showing us, kind of that stuff in the middle, and how that's best represented. So I've used, some terms here. And so when we talk about that range, we want to know, of those, the upper limit and the lower limit, the range is kind of the true limit. What is the absolute top measure and what's the absolute bottom or response, top response and bottom response. And then you've got the interquartile range where it's divided into um, um, four different for equal slots and equal groups. And then the variance is, which uh, statistics measures, kind of how much variation do we have in the whole process. So one of the tools that I use when I want to just kind of get a sense of what I'm looking at, is to have the printout that you see down at the bottom of your screen. It's a little small, but we've got the variable number there. Um, and then, it automatically calculates, what the mean score is, as well as the standard deviation or the variance there. We can see the minimum value. So some people reported one, some people reported three. The median is that some people, most people reported one. And so then we can actually see the frequency, how many people reported one, two, and three. And so that can, kind of give us a little eyeball there that, yeah, okay, that middle value would fall under one. And then it gives just a little very basic graph just to help provide some visualization there. And then what's really cool is that it tells me how many are missing. So, and should this, is this a particularly large number that I should be concerned about? A lot of times when you're dealing with large statistical data sets, you want to have it be at least less than 5% missing. And so in both of these cases, less than 5% of our data are missing, in which case it was good enough for me to run with. And I mentioned earlier, the standard deviation. So this is part of, the way in which we, kind of measure how wide is the distribution, and the variance within it. So I mentioned earlier, when we've got that normal distribution, it should look like a bell graph, where it's centered around the mean, which is the most popular, or yeah, the average, you know, the average person, where are they most likely to fall on the scale? And then the number of cases then that are, off to either side, that are much less. And so with all of that, we'll keep going. So I mentioned here talking about, our relationships among the different variables. We can use a cross tabulation. Usually it's just two variables, and that kind of keeps it simple. And then but sometimes, you can have more, like I showed you earlier in my mosaic plot. In this one, you've got, um, you know, the sports that people like to play, and, broken down by gender. And so, how many people liked, how many males liked baseball? 12. How many males liked basketball? 25. How many females liked football? 12. So we can see that breakdown. Now, then there's also something called the marginal distribution, and those are the totals that you see under each of those categories. So the cross tab technically are the gray numbers, and then the marginal distributions are the black numbers. So just to kind of keep those in mind. It wasn't as clear in your textbook, so I thought just make it a little more clear here. And so, when we also, another way of describing some of these relationships, sometimes having that type of those categories is not as appropriate. And so we might want to use a scatter plot. And so this can be a graph, and I'll show you one in a minute. Um, and so as we think about describing all of these relationships, then, we want to kind of ask ourselves, what types of associations are there? Is there any relationship between the variables, theoretically, based on what we know, or based on what we can see here? How strong is the relationship? So that's something we can measure. What's the direction? Is it when one thing goes up, the other thing goes up? Or is it, that's a positive relationship? Or is it that a negative relationship? When one thing goes up, another thing goes down. Um, and then is it kind of a linear, or is it a quadratic, or is there other types of, relationships? And then, there's these measurements of association. And so this is a way of describing it that can describe then the strength of that association. So perhaps you've remember hearing about correlation, a correlation coefficient. And so this is a statistic that can summarize both the strength and the direction. So if it's closer to A1, whether it's a positive one or a negative one, the closer to the one it is, the stronger the relationship. The closer to zero in the middle, the weaker the relationship. And then whether it's a negative relationship, it would go towards -1, or if it's a positive relationship, then it would go towards +1. If it is a value of 1, absolutely, then it is a perfect correlation between them. That you really never find in lived society or in any kind of biological sciences. It's sometimes you can get quite high, but a lot of times, we'll consider anything above 3 or 4 or 5 to actually be a decent relationship, even though it may be a little bit lower. So I mentioned, kind of the scatter plot. And so each point here would be one person's individual response. And so, this looks at the test scores by the number of hours studied. So the person at the lowest, maybe they only studied for, I don't know, a little over 6 hours, and they only got a 20 on their exam. And another person only, they spent less than 5.5 hours studying, and they got at best, less than a 60. Whereas people who spent, closer to 9 hours got close to 100 on their exam. So here you might assume that there's a positive correlation. And right down at the bottom of the screen, it indicates correlation was 0.837. So that's actually a really strong correlation that between the two. It's strong, meaning that it's close to 1, and it's positive as opposed to a -1. So if the score goes up as the hours also went up. Alrighty, so some of the implications then for all of this is that you know the test that you choose has ramifications for your outcomes. And so sometimes you'll just do a simple test between two variables. However, we know that in society, nothing is ever simple. And as social workers, we also know that, we live in a world of systems. So yes, a parent can, parent a child in a certain way, but the child is going to be learning things, and it's going to be treated by society in many, many other ways that are going to have bearing on that child's upbringing and how they grow. So, yes, you can do some of these simple tests, such as a chi-square or a t-test. And sometimes that's all that you can do because that's all the data that you have. But a lot of times you have more data, and so you can begin to control for some of those or account for some of these outside influences, such as racism, levels of education, their income, how much financial resources do they have at their disposal, maybe their marital status, are they able to tag team and partner up and thereby have less stress, or is everything kind of being put onto one person? So, you know, as we bring some of these additional variables to bear, it gives us a much more robust understanding out of our statistical test. But it requires that we do different tests. And so, for instance, multiple or logistic regressions would then be the appropriate tests for those. Others, we would then, when we talk then about this idea of statistical significance, there's general rules of thumb that many scientists adhere to, but there's also a degree of nuance. And so, kind of relegating these to absolutes can be a little bit dangerous, especially when we're talking about, social science. So when we talk about statistical significant, or if a finding was statistically significant, this is the likelihood or the probability that the association that we found, statistically speaking, is due to change. And that's, according to a set criteria. So oftentimes we will say the probability of an association is due to chance is less than 5 out of 100, meaning that okay, you know what? There's a 95% chance here that what I found is actually due to the relationship and not something that's just random. There are and so this p value, as it's often termed, or the probability, uh, the baseline generally will be 0.05, that we want our p value to be less than 0.05. Sometimes you'll actually see the p-value it's specifically identified. So, so we'll actually indicate what was the p-value, not just it was less than 0.05. Sometimes you'll see it as asterisks. And so this is a shorthand. And down in the notes of your graph, you will then see that, okay, one asterisk indicates that the p-value is less than 0.05, two asterisks less than 0.01, and three asterisks is p-value is less than 0.001. So that would be less than the chances of it happening are less than 1 in 1,000, that it's due to some random thing. Now, uh, there's no like, I mean, there's nothing that says that, if you're have a 0.06, that your finding is statistically insignificant and you didn't find anything. Honestly, it's kind of an arbitrary thing. And so I personally feel, and there are many other scholars out there who are like, yes, we can identify according to common convention that our finding was statistically significant, but it doesn't mean you just throw out everything and that there's no meaningful findings, because it could be meaningful, but maybe you just didn't have enough data. And so this hints at, that hints at a finding that may actually be there. Um, so you shouldn't just discount something because it's non-significant according to standard conventions. And so this kind of gets this idea of type 1 and type 2 errors. Um, So, a type 1 error occurs when you've got evidence, when your statistics say there's a relationship, but there really isn't. And a lot of time that would be if you've got too much data, in which case then you can find any type of relationship, and it might be a really tiny one. So should you really be putting, credence in that? So you need to use your logical thinking. And you need to know your field and you need to know the theory. And then there's the type 2 error, which would say that, maybe you didn't have enough data. And so there's no statistical evidence that this was significant. But in fact, the variables are related, and we do know that. So this would be, for instance, if your p-value was at 0.06, just above the cutoff, but it's definitely worth looking at still, and could direct you in a way that is like, hey, there might be something here. We need to keep looking and looking deeper and maybe doing more research. So as we consider all of this, we want to really make sure that we are representing diverse populations in our statistics and not just going for who's easiest to grab. Um, a lot of times, we're going to need to do different types of analysis. Um, and rather than lumping everybody together, to be able to understand and get at the nuance of what is actually happening. We live in a society where there's a lot of white people, and a lot of white people say this is how stuff is done. Meanwhile, we've got other people, who are like, I do things differently and I do things this way and it works for me. And so we're just simply ignoring that other way of being. And so, that's where we need to better understand and maybe start doing some analyses that bring to light these different ways of thinking, these different experiences, these different oppressions that are being experienced. And so, sometimes we need to have between, comparisons between groups, but also recognize that sometimes the tools that we're using are not appropriate between different groups. And so you need to kind of use a tool within one group so that way everybody is being measured in the same way. Just to give you an example here, when I was looking at my dissertation, I wanted to explore what were some of the financial experiences that people were having, and their perceptions of these experiences, and how might it contribute to the racial wealth gap. And so I compared people who identified as Black and people who identified as white, and to see, how are their experiences independently being understood. Now, one of the findings was, because I put together a model for this, is that my model did not work well for people who identified as Black. It worked very well for people who identified as white. Now, I didn't come up with the questions. I just picked ones from a pre-formulated list of data. And so what that told me was that, oh, okay, you know what? There's something here, and there could be some racial bias, and there could be some ways and worldviews that are being measured according to a white worldview as opposed to the Black worldview. And so we're missing a big part of that picture. The fact that my model didn't work was actually really illustrative of some of the problems in statistics and in data analysis, and problems among these data gatherers, these big foundations that were doing these surveys, that they were missing perspectives. Then another piece here was that what I found was that Black respondents were just as willing to take risk and to invest as were white ones, white respondents. Now, this was actually contrary to um, other research findings. And so what I understood from this was that sometimes they just simply don't have the money to do it, but the willingness to do it is certainly there. And so this would be an impact of structural racism. Then, when we also, I was only able to categorize folks as being Black, but I knew that there would be probably some pretty big differences based on historical treatment between folks who were African American, folks who are Caribbean and African immigrants, and as well as then folks who are maybe bi or multiracial. So understanding these familial influences, these cultural influences, the impact of slavery and traumatic experiences and how those would be perpetrated versus growing up in a society that one was not experiencing slavery. If they were, say an African immigrant, how does this impact then their willingness to take risks and their willingness to work with families and rely upon their community networks? So there's a lot of stuff that needs to get unpacked there. And so we need to then bring this understanding of social justice to our data because, especially as social workers, because a lot of economists are not including these things. A lot of other disciplines are not looking at them in this way. So it's really important that we do. Ultimately, then, we statistics are, they take a ton of information and summarize it in just a few numbers. And so we need to unpack the story behind that number. So it's important to make sense to understand the context of the research question and to provide all of that nuance so that way it's not misunderstood. It's also important to recognize that statistics, as I mentioned at the very beginning of our course, has had an origin in trying to prove racial superiority. So it's got some pretty dark, roots. Um, and so using these tools for good is a real important task for us. And even today, a lot of social scientists will say, due to race, or a difference due to race, and that's actually not, good as a variable. It's a difference due to racism. Um, and then maybe they only present a dichotomous gender, as we saw earlier on. What about folks who don't identify? They are being missed. We identified earlier that, folks had to be either married or single. And so what about people who are cohabiting and didn't believe in the institution of marriage, but were in long-term relationships nonetheless? So, there can be bias in how uh, this research is being collected and interpreted. It could just simply be we didn't have enough of it, so that enough statistical power, or perhaps we approach it from a very concerted effort towards social justice and really try to gather much more perspective from people who have been overlooked before this. So lots of social justice implications in quantitative data and quantitative data analysis. I will leave you with that. Thanks so much.